Hi, welcome to Technical and Engineering Academy. This is Blessed Elvis. Okay, so guys, today let's do the homogeneous differential equation. The homogeneous differential equation are equations of the form where you have dy over dx equals to some functions. Let's say on top we have f of x and y, and down here we have g of x comma y. So some of the things we need to understand is that for the function on top, you need to have the same degree with the function that is on the denominator. So whatever function that you are given, you need to write it in this standard. After you write it in this standard, after you have simplified, then you let y equals to vx. So whenever there is y in the expression, you have to replace with vx. So after you do that, in fact before you do that, you have to differentiate in advance. So this expression, you also differentiate it. You have dy over dx equals to, we know when we differentiate v here, we are going to use product rule on this side. So when you differentiate v, we are going to have x dv over dx, then plus, when we differentiate x, it's just 1, so we are going to just have v. So that's it about homogeneous equation. Thanks for watching. Oh, yo. I'm just joking. But anyway, that's the fact behind this. Always, after you simplify the expression, always relate y equals to vx. After you do this, you differentiate this expression. After you differentiate this expression, you replace the values now in the given expression. So meaning, where is dy over dx in the expression, you always replace with this function. And where there is y, you replace with this function. After you replace, then you factorize x. After you factorize x, you remain with some functions. After remaining with certain functions, or rather equations, you make them separable. After making them separable, you integrate. Then you replace again where there will be v with the answer that you will have, or rather it might even go direct. So where there is v, we know that we have y equals to vx. So here you just make v the subject of the formula, of which we know we are going to have over x here and over x here. Then you have this. So in this case, then our v then means it is equals to y over x. That's all about this. So let's just summarize this. So firstly, step 1, you let step 1, you let y equals to vx. You differentiate the expression. You say dy over dx equals to x dv over dx. Then you add v here. After you do that, you make v the subject of the formula if that's required. Or after you do this, you have v equals to y over x. Okay, so that's how this is done. So after you replace these values here in the given expression, you factorize x. After you factorize x, you cancel x values, and then you make the expression, or rather the equation, separable, and then simplify. After you integrate, you get your answers. That's all about it. You will see this. Let's just get to an example. Let's say you have 2xy rather, 2xy plus x squared dy over dx equals to 3y squared plus 2xy. So if you still remember the first step, we said you write in the form of a function of f over function of g. So you have to divide this to both sides so that you just remain with dy over dx. So on the left side, you always have to just remain with dy over dx. So you divide 2xy plus x squared, even here 2xy plus x squared. So this and this cancels. You just have dy over dx on the left side equals to 3y plus 2xy over 2xy plus x squared. So we have this as the simplified expression. So this is the part where I said after you have simplified, you have made here this part to only have dy over dx, then you let, so here this is where you let y equals to vx. So in that expression, wherever there is y, we will replace with vx. Okay, so where I mean here, we have the function dy over dx equals to 3y squared plus 2xy over 2xy then plus x squared. So in this expression, wherever there is y, we are going to replace with vx. Let's also differentiate this. Remember we had done this, so we had dy over dx equals to x dv over dx, then plus v here, v. Okay, let me just not write it from here. Okay, so over x, just bear with me, plus v here. So whenever there is dy over dx in the expression, we are going to replace with this function, and whenever there is y, we are going to replace with this function. So let's do that. So here, where there is dy over dx, we have x dv over dx plus v equals to 3. Remember, where there is y, we will replace with vx. We have squared here plus 2x, where there is v, we replace with vx over 2x, where there is y, we replace with vx. Again here we have x squared. So we have this. Let's simplify it. Okay, so remember on the left side we have x dv over dx plus v equals to, so in this case let's simplify. So we have vx squared, so this is the same as v squared then x squared plus 2x. Remember we have 2x then xv, so x multiplied by x, it's x squared. So in this case we have vx squared over, down there we have 2xy, which means we replaced with vx, so we are going to have 2x multiplied by x, it's also x squared, so we are going to have 2vx squared plus x squared. So here we can factorize x squared since it's common on both the numerator and the denominator. So let's first factorize x squared. So here we have x dv over dx plus v equals to x squared 3v squared plus 2v over x squared will remain with 2v plus 1. So we can cancel x squared and x squared here. Okay, so after we cancel this, we are remaining with x dv over dx plus v equals to 3v squared plus 2v divided by 2v plus 1. So as we can see, we can simplify this further by getting this come to the right part, so that here we just remain with x dv over dx equals to 3v squared plus 2v over 2v plus 1. So when this comes to the right part, it will be negative of this. So we can simplify this further where we find the common denominator. So the common denominator here, we know, okay, let's just write here first. dv over dx. So the common denominator here we know is 2v plus 1. So when we divide 2v into 2v plus 1 into 2v plus 1 is just 1. So the left side will just come out the way it is. So we will have v squared plus 2v. Okay, then minus. Remember here we have v. 1 divided into 2v plus 1 is just 2v plus 1. So we are going to multiply this 2v plus 1 with v, which is on the right side. So we are going to multiply with 2v plus 1. Okay, so in this case, let's simplify this. So we have x dv over dx equals to 3v squared plus 2v. Now when you multiply v into with 2v, we are going to have 2v squared, and then negative v of 1, we are going to have negative v over here we are going to have 2v plus 1. So in this case we can as well subtract this and that, and also this with this. So 3v squared subtracted by 2v squared, we are going to have v squared. Then 2v subtracted by v, are going to have v. So here let's just write this. So we have dv over dx equals to, so we are going to have v squared plus v over 2v plus 1. Okay, now we have made this expression a separable differential equation. So now we are going to use the rules on the separable differential equation. So if you didn't watch a video on separable differential equation, please do watch, so that whatever we are going to do, you will have an idea. So here we are going to cross multiply. Okay, so we multiply 2v plus 1. We multiply it with x dv equals to, we are going to multiply dx multiplied by v squared plus v. Then here we have dx. So in this case we can simplify this. Here we are integrating with respect to x, but we have v. Here we are also integrating with respect to v, but we have x here. So let's divide this. So let's begin by dividing this to both sides. Even here, so we cancel this and that. Okay, so on the left side now we have 2v plus 1 x over v squared plus v. Then here we have dx. Equals to, here we just remain with, sorry, instead of dx here we have dv equals to dx. So remember we have a coefficient x here, so we have to divide it also. So we are going to divide over x, even here over x. So we cancel this x and this x. So here we just remain now with 2v plus 1 over v squared plus v dv equals to 1 over x dx. Now we can integrate these expressions, since we have the integral of v with its respective coefficient and the integral of x with its respective coefficient x. So now the integral of this fraction of this kind, we have done the differentiation, or rather the integration on the fractions. So make sure that you watch the video to have a clear picture. Now here, when you are integrating such kind of an expression, you differentiate the top. Here you are going to have 2, and then you also get the power of this, which of course we have 2. So here we are going to have 2 divided by 2, and then ln of the denominator, which is v squared plus v, equals to the integral of 1 over x is just ln of x plus the constant c. So in this case we can cancel this 2 and this 2. So here we just remain with ln of v squared plus v equals to ln of x plus constant c. Now when we have this, remember this is a constant, so it can be any value. So writing like this, it can also be written in this form. So v squared plus v equals to, this can also be written as ln of x plus ln of c. It does not make any difference since it's constant, so it can be any value. Now according to logarithmic rules, when you are adding the logarithms or ln or logs, when you are adding them, it means that you are multiplying the two, and then when you are subtracting, it means you are dividing. Okay, let's get sense from this nonsense. So here we have ln of v squared plus v equals to, here what I mean is this is the same as we are multiplying x with the constant c. So we can easily cancel ln since it's common here. Of course we can divide. When we divide ln here and ln here, we will cancel. So here we are just going to remain with v squared plus v equals to cx. Now remember, we had only borrowed this v because we had y equals to vx. So here let's make v the subject. So we divide x here and x there. So here we have v equals to y divided by x. So whenever there is v, we are going to replace with y over x. So in this case, then we are going to have y squared, we are going to have y squared over x squared, then added to y over x equals to cx. So now by the rules, it means you are done here. So what's just remaining is to simplify this expression. Okay, we know that x squared is common here. So if you want, you can say, okay, let's just create space. So you have y squared over x squared plus y over x equals to cx. So we can find the common denominator. We know it's x squared. So x squared into x squared is just 1. So we have y squared here. Then x into x squared is just x. Then x multiplied by y is just xy equals to cx. So we can cross multiply here. So when you cross multiply, we are going to have on the left side, you are going to have y squared plus xy equals to, when we multiply x squared with cx, we are going to have cx cubed. So then we are done. So this is the idea behind the homogeneous differential equations. So at first, if you remember, I said you always write the expression in form of dy over dx equals to the numerator function and the denominator function. Then after you are done with that, you always let y equals to vx, and then you replace wherever there is y into the expression with vx. After you replace, you factorize x. After you factorize x, you cancel the values of x. After you cancel the values of x, you simplify the given expression and then integrate. After you are done with integrating, you are going to have v into the expression. So you have to replace where there is v with y over x, then you are done. So that's it about ordinary differential equations concerning homogeneous. So no matter how long the equation can be, the idea behind is just the same. Okay, let's just get another example here. Let's say you have dy over dx equals to y over x, then we add it to x sine y over x. Oh, this one looks different, right? Yeah, I know what you are thinking. Okay, we are thinking the same thing. Okay, now here always I said, now this side we have already been given that there is already dy over dx, so there is no need to simplify this further. So here we can just go direct, where you let y equals to vx. But you see here, we have y over x. So in this case, when we come to simplify this, we have to simplify y over x. So how are we going to do that? We are going to divide x here and x here. So here we have v equals to y over x. Yeah. So whenever there is y over x, we have to replace with v. Yeah, that's it. So, and again, before we go any further, remember we have y equals to vx. So let's differentiate this. So we know this is the same as this when we differentiate. We have done this already. Okay, so here we have v. It's just the same expression if you have followed me from the beginning. So whenever there is dy over dx, we are going to replace with this, and whenever there is y over x, we are going to replace with v. Simple, right? So into the expression where there is dy over dx, we replace with this, and where there is this, we replace with v. So let's do that. Okay, so where there is dy over dx, we have x dv over dx plus v equals to, where there is y over x, we have v plus x sine v. Okay, so let's take the v to the right side. Of course, here we are going to remain with x dv over dx equals to v. When we take this to the right, we are going to have negative of that. So here we have x sine of v. So this and that will be subtracted. So here we just remain with v dv over dx equals to x and then sine of v. So on that part where I said after you are done with this part, you factorize x. So in this case, x is just cancelled, because when we divide x here and here we divide x, this and that cancels, and this and that cancels. So here we just remain with dv over dx equals to, here we remain with sine of v. So now we have expressed our expression into the separable differential equation. Now, since we have done that, let's now simplify this. Okay, so we can cross multiply here. Here we have dv equals to, we can say sine v, then dx. Okay, so we are integrating this with respect to x, but here we have v. We are also integrating this with respect to v. So we have to take this which has v to the left side. How? By dividing sine v to both sides, even here divided by sine v. So we get rid of this. So here we are going to have 1 divided by sine v dv equals to, here we just remain with dx. So we know by trigonometric rules that 1 over sine is cosec. It's just cosec. So in this case we have v dv. So it's just the way of simplifying this so that we can integrate easily. But if you want, you can even integrate from here. It does not matter. So here let's integrate now. Okay, so integrating cosec, always when you're integrating cosec, it gives ln then tan of the variable present over 2. So here integrating dx, we have x then plus the constant c. Now remember, where there is v, we had said v equals to y over x. So we have to replace where there is v with y over x. Okay, so let's do that. So here we have ln tan, then here we have we can just say 1 over 2, and then we have y over x equals to x plus constant c. So in this case we can multiply what's inside there, so that we have ln of tan 1 multiplied by y is just y over 2 multiplied by x is just 2x equals to x plus constant c. So now we are done. So that's the idea behind the homogeneous differential equations. So make sure that you have the concept. Let's just summarize what we have done so far. Always you simplify the given expression where you have dy over dx on the left side, always only dy over dx on the left side. Then you have the function of the form comma y over gx comma y. So make sure that they are of the same degree. In the next video, we will do the non-homogeneous differential equations so that we see how that is done whenever you have different degrees. So after you do that, you always let y equals to Vx. Then you replace into the given expression. After you replace there, also you differentiate this equals to x dv over dx plus v. So where there is dy over dx, we replace with that. So you replace where there is y with this. You also replace where there is dy over dx with this. After you are done with this, you simplify now, or rather you factorize where there is x, you factorize x. After you factorize x, then you make the expression become separable. After you make it become separable, you integrate and simplify. Remember, in the final answer you are going to have where there will be v. So you replace where there is v with y over x. So that's it about homogeneous differential equations. I hope that you have understood and gained understanding. Thanks once again, guys, for staying this far. Please like, subscribe, share, and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.